Inside the kit, you can see it's too long, so I've rolled it up, but there is a NeoPixel strip with 30 pixels. If you look at this now, it has 3 pins, and there is a compatible harness cable that allows for compatibility between the NeoPixel side and the expansion board side. This part here is currently the female connector. The male part here, which is currently protruding, should be inserted into the slot here. And now you can see the 3 pins coming out. Please connect this 3 pin to the part labeled Y11. Next, please very carefully connect this module like this and securely. This means you are ready. Last time we opened the code. Now, if you open the library folder, you will see NeoPixel here. However, for this NeoPixel to operate normally, you need to install another module, library inside it. If you go to this link, you can now view the source code page for Adafruit PyPixel buff. First, you need to carefully copy this file name exactly as it is shown, and then proceed to create a new file, right here in this location. Next, please copy the entire code snippet from the source and paste it into the designated area here. After pasting, make sure to save the changes properly. I'm just ready. In this state, I'll simply try writing the code. Import. From line import. From line board, NeoPixel, board, NeoPixel, NeoPixel, board, board, and here you can see the NeoPixel, which is probably the one NeoPixel module we saw earlier, located on top of the module. That's relevant to that. And this time we have connected it to Y11. The number of pixels is 30 and the brightness is 0.2. Set light to false to update while true, and fill pixels with red. This is RGB. Update with pixels.show with the tuple 255.0.0. To adjust the settings, you can follow this method. Set the values to 1, 1, 1 for the color green, and similarly, use 1, 1, 1 for the color blue. This pattern can be applied to other colors as well. For instance, if you want to adjust for red, you might consider using a different set of numbers. This approach allows for flexibility and customization in color settings, ensuring that you can achieve the desired outcome for each specific color you are working with. Let me check it once. As you can see, the colors are changing in order: red, green, and blue. This is how it is, and if you think about it, you are currently controlling all the pixels. But if you want to control specific pixels individually, let me explain it to you. Now, by connecting to the console, opening the serial monitor, and pressing Ctrl+C and Enter, you are now connected here. Right now, at this very moment, I've carefully inputted this particular data and brought it up to this specific point. And I will intentionally proceed to delete up to the 3rd line, making sure to include the pixel in the process. Set the pixels. Fill 2, 0, 0, 0, and then call pixels. Show. After the update, everything is turned off. In this state, if I check the number of pixels, it will show how many pixels I am currently controlling. Since the pixels are now managed in an array-based format, in a structured manner, if you want to change the value of the first pixel to the color red, you would specifically set the first pixel, which is 0, to 2550. Then, When you update the pixel, you can see that it has changed to the color red. For instance, in this particular state of affairs, the course of action that I decided to undertake involved proceeding in a manner that was both deliberate and carefully considered, ensuring that each step was meticulously planned and executed. Pixels 2 is exactly 0, 0, 0. When you do this, you can set the colors to red, green, and blue individually. You can do it this way. So, if you don't need to show, every time you change a pixel, you can update all the pixels you want to update first, and then finally, when you want to display the animation, you can show it as one frame. Once it's completed, you can show the pixels all at once, and then update each pixel like this to display it. Alternatively, if you want to control everything, you can change all the pixels at once as shown in the code. This is how you can control it. This time, we explored controlling NeoPixel with CircuitPython. I will come back with different content next time.